Hello, geometry. Here we go with lesson 5, which is inscribed angles. I would say that this one causes people trouble until they get it. And then when they get it, it's like, oh, this is really easy. So I'm going to try and pinpoint what makes an inscribed angle to help you with hopefully getting it quicker and therefore making this an easier lesson. So an inscribed angle is an angle formed by two chords whose vertex is on the circle. Make a big note of that word on. The vertex is on the circle. Okay, that's what makes it an inscribed angle. The measure of the inscribed angle is half the measure of the intercepted arc. And you're going to hear me say intercepted arc again quite a bit. All right, so in circle O, angle B is the inscribed angle, or angle ABC, you could also say. The intercepted arc is AC. So if I'm looking at the arc, and I'll change to blue so you can see it better. If I follow the angle to where it hits the circle, basically making a chord, I hit A and I hit C, so the intercepted arc is AC. All right. Now, if the measure of angle B is 21, so if that is 21, what's the measure of arc AC? It's using this relationship here. The angle is half of the arc. So 21 is half of AC, so AC would be 42. If AC is 70, then the angle would be 35. It'd be half of it. Okay. So that's the main relationship with inscribed angles that I want you to see. It's a little different than central angles, which we've done pretty much up to this point has all been central angles. The central angle is equal to the intercepted arc. The inscribed angle is half of the intercepted arc. Oops. Scroll down just a little bit further. All right, so got 3 examples here. Some easier than others. Find the measures of each indicated arc. So angle, and make sure you look at those symbols. Very, very important here. I'm looking for an angle. Measure of angle ADB. So that would be this one. Okay. Well, if I follow angle D and I follow it up to the circle twice, I find that the intercepted arc is AB. So that angle is half of 76, so 38 degrees. Okay. Arc DC, I'll change color so you can see a difference here. So I'm looking for an arc this time. Well, the arc I'm looking for has an intercepted or an inscribed angle, angle B, right? So that's the intercepted arc that I'm looking for. So 45, double it, I get 90. Right. Next one, I'm looking for angle POQ. Now that's not an inscribed angle. It's also not an arc. That is a central angle, right? Well, how am I going to find that? Well, if I'm looking for that angle, isn't that equal to its intercepted arc? Central angles are equal to its intercepted arc. The intercepted arc is PQ. So if I can find PQ, I will have X. All right, so just write down what I just said there. So angle POQ, which is X, is equal to the intercepted arc, which is PQ. Well, how am I going to find that given what I have? Well, I'm given a 62 degrees down there, and that's an inscribed angle. So angle R is an inscribed angle. Its intercepted arc is PQ. Wow, imagine that. So the inscribed angle is 62. The intercepted arc is double that. So double 62, I get 124. So arc PQ is 124, which means the angle POQ is also 124. Okay. Arc CD. So I'm looking for arc CD. Here's what a lot of people are going to do. They're going to say, oh, look, it makes a line. BD makes a line. It's a chord. So that's 95 degrees. And that's true. That is 95 degrees. So X is 95. Wrong. X is not on the center. That's not a central angle. That does not work here. So what am I going to do? Well, I could probably do a couple different things. But what I see here is that CD is the intercepted arc for both angle A and angle B. So if I could find either angle A or angle B, then I would have enough information to find arc CD. Well, I've given 85. I don't know what angle C is. I also don't know what angle B is, and there's really not a way to figure that out. I have that 32 degrees down there for angle D. Okay, there's a couple different things I could do with that. But what I see is I got vertical angles here. So this is 85 right here. I have two angles in that triangle. Now let's do 85 plus 32 and subtract that from 180. I get 63. So angle A is 63 degrees. If I double that, I get arc CD. So 63 times 2 is 126. All right. To the back. Some tougher problems. So I'm looking for A and I'm looking for B. B is probably going to be the trickier one. Maybe not too bad here. I see that A is arc PT. Arc PT, if I follow it down, follow the two lines, I find that angle Q, and not just angle PQT, is an inscribed angle. And from there, I see that that's 60 degrees. So A would be double that. So A is 120 degrees. B, on the other hand, if I follow the angle marked with B, I get to P and I get to S. So arc PS is the intercepted arc. Well, PT was 120, right? I gave you this 30 here. So that full arc is 150. And that means B is half of that, so 75. All right, the next one, everything's set up the way you need it to be, but it's all algebra. So this is the angle. The intercepted arc is 5x plus 60. So how do I write this equation? Well, the angle, 3x plus 25, is equal to half of the intercepted arc. So 1/2 times the arc gives me the angle. So 5x plus 60. Okay. Now, I don't like to deal with fractions, so I'm going to get rid of it. I'm going to multiply both sides by 2. And that actually gives you the other way you could have done this. The other way people look at it is if I double the angle, I get the arc. It's a little easier way to look at it maybe for some of you. If I double this angle, I get the arc. So double the angle gives you the arc. Okay, either one of those equations would work. 6x plus 50 equals 5x plus 60. Subtract 5x and subtract 50, I get x equals 10. You can plug it in to make sure. 3 times 10 is 30, plus 25 is 55. If I double that, I should get 110. 5 times 10 is 50, plus 60 is 110. Okay. Now we're moving on to, it's still an inscribed angle, but it's going to look different. The measure of an angle formed by a tangent line and a chord is half the distance of the intercepted arc. So that picture there is what I'm showing you. So for angle CBA, that's not a 90-degree angle. We talked about that with tangent lines. That's not a 90-degree angle because it doesn't, the line, the point of tangency is not connected with a radius. So don't think you're finding something cute here and saying, oh, that's 90. It's not. Angle CBA, where's the vertex? The vertex is on the circle. There's that big word again. It's a small word, but it means a lot. The vertex is on the circle, which means it's an inscribed angle. The intercepted arc is arc AB. If you look at it, follow the line, like I've said, and it hits at A. If you follow this line, it'll never hit again, right? It's a tangent line. It'll never hit again. So the only place it hits is B. So that whole arc is the intercepted arc. Since it's an inscribed angle, it's half of the intercepted arc. Well, the intercepted arc is 148. Half of that would be 74. Okay. Do some practice with that idea down below. At least a couple of them. So first one. Inscribed angles here, the intercepted arc would be this one. I don't have this one, but I have 220 on the other side. Well, from here all the way around is 360, right? 360 minus 220 would give me 140. So my arc is 140, meaning X is 70. All right, next one. I got that 54 degrees. I've got an isosceles triangle. So from that triangle, I know that this angle and this angle are equal. Might help me, it might not. Back that up. Okay. I've also got congruent chords, right? So those two lines mean that those chords are congruent, which means these arcs are congruent. Okay. I also have 54 degrees as an inscribed angle. So this is an inscribed angle. I could find arc right here is double 54. So 54 times 2 is 108. And then what I can say is, well, since these are equal, I'll call it W and W means 2W plus 108 has to equal 360. Now, could you do this a different way? Absolutely. I'm just showing you a way to do it. You get 126 for those two arcs. So angle Y, or Y, I guess. Let's just start with X. You know what? Let's look at X. So X, the intercepted arc is the 126. So X is half of 126. So 126 divided by 2 is 63. Y is an inscribed angle as well. Its intercepted arc is also 126. 126 divided by 2 is 63 again. And then Z, its intercepted arc is 108. Half of that would be 54. All right. We'll go ahead and clear that, give myself more room for the next one. When you get something that looks like this one, you got a lot of different parts along the outside, might be a good idea to find the missing parts. So what I mean by that is around the outside, find EA, find ED, find BC. Well, BC, arc BC is what I'm looking for. That's one of them that I'm looking for. So I'll go ahead and put that there. I'm also looking for angle B, so I'll put a Y right there. Okay. Now I'm going to go through and what I have and try and figure out those missing arc lengths or arc measures, I guess. Well, I see EC as a diameter. I like to look at those diameters. Those help a lot. EC is a diameter, which means it's 180 degrees. So the semicircle is 180 degrees. I've already got this 112 here. 180 minus 112 is 68. So ED is 68. Okay. I could do the same thing on the other side, but EA plus AB plus BC would equal 180. And I don't know two of those, so it's not going to help me. What is going to help me? Well, I got this 51 degrees right here. 51 degrees is an inscribed angle. If I follow it, the intercepted arc is BE. So 51 times 2 means that from E to B is 102. Well, if that's 102 and this is 72, EA would be 30. And now I should be able to find X. I can do 360 minus 112 minus 68 minus 30 minus 72 to give me what's left. Or I could just do 180 minus 30 minus 72. And I do that and I get X equals 78. Now, angle B is Y, right? It's an inscribed angle. I'm going to change colors. Hopefully this one stands. I'll go green. Its intercepted arc is A all the way around to C. So it's actually a major arc. Goes a little bit more than 180. But I just went through 3 arcs that I've already found the measures for. I went through 30, 68, and 112. If I add those up, what do I get? I should get 210. So the intercepted arc is 210. The angle is half of that. So angle B is 105. If you find those missing pieces, you can just use the pieces that you need to find the information that you're looking for. Okay, I know that looks like a disaster there, but hopefully you were able to follow that. And that's it for inscribed angles.